So in this video, we are going to discuss about digital to analog converter. It is used to convert a digital signal to analog signal. So clearly, first we are going to see about weighted resistor type DAC, and another one is R2R ladder DAC. Okay. So why it is called as weighted resistor means here instead of a single resistor there are two power values of the resistors added. Okay. So first let us discuss about weighted resistor type. DAC. So consider we are going to convert the 3-bit DAC. Okay, 3-bit DAC to we are using 3-bit DAC. So their values are D1, D2, B1, B2 and B3. So this is your LSB and this is your MSB. Okay. So their values are 000, 001, 010, 011, 100, 101 and 110 and 111. So totally you have 8 values. Okay. So the general circuit diagram look like this. Okay. It is connected to a inverting amplifier. This is 2R and this is 2 power 2R and this is 2 power 3R and 2 power N0. Okay. It is connected to minus VR. Okay. So this is nothing but since I have taken only 3-bit, n is equal to 3-bit, this will actually look like this. Okay. So what is this value? This is nothing but your MSB and this is nothing but your LSB. So these values are B1, B2 and B3. Okay. Consider I am going to give for this one. Okay, this is the input that I am giving. So what will happen? My circuit will look like this, right? Will look like this, right? So this and all will not be connected to the my circuit. Okay. So let me take this one as my I1 and this is I2 and this is I3. Since it is not connected, I2, I3 value is 0. Okay. So this current only, it is flowing through this through this one. Okay. So if I take I0 value is equal to I1 plus I2 plus I3. Okay. So this is my I0. Okay. This is my I0. The I0 current is nothing but addition of all this current. Since the I2 and I3 current is 0, I can take it as I0 is equal to I1. So this I0 current only, I0 is nothing but I1 that is flowing through this V0. So I can write 0 minus V0 is equal to I0 Rf. So that is nothing but V0 is equal to minus I0 Rf. Okay. So what is my I0? I0 is nothing but I1 Rf. Okay. So from this diagram, I can write I1. What is the value of I1? Minus Vr to 0. Minus 0 divided by 2R. So this is nothing but my I1. So you substitute this value here. If you substitute the value here, you will get Vr by 2R into R. Okay. This is your V0 value. Okay. So what is V0 now? V0 is equal to Vr divided by 2R into Rf. So let me take Rf value is equal to 4K. Okay. And 2R value is equal to 5K. Okay. So I need to get the value as 4, right? 4 volt. For this one, the equivalent value should be 4 volt. So I need to get 4 volt here. So in order to get 4 volt, if this is 5K and this is 4K means definitely the VR value must be 5. Okay. So if I solve, I will get 4 volt. Okay. So this is nothing but 1 milliamps into 4K. So this is nothing but 1 milliamps into 4K. That is nothing but 4 volt. Okay. So what will happen, suppose instead of this I1 is equal to 1 and the rest it is 0, 0. If I take I2 is equal to 1 and I1 and I0 is 0. Okay, for this value. So if this value is taken, I have to take instead of 2R, there should be 4R. If it is 4R, then this value must be, this current value must be 0.5 milliamps into 4K, right? So if that is the case, that this value should be 2 volt. Okay. So if I take I3 is 1 and rest it is 0, 0 means it should be, instead of 2R, it should be it has to be divided by 4, right? This has to be divided by 4. If it is divided by 4, that value should be 0.25 milliamps into 4K. So this value is 1 volt. Okay. So this is obviously 0 because there is no current is flowing here, right? This is 1 volt because this is 0.25 milliamps into 4K. Okay. So what about this one? So here these two current are flowing, that is I2 and I1 current are flowing, that should be added, right? So this is I1 current, this is I2 current, right? This is I1 current and this is this is I3 current and this is I2 current. So if I add this one, these two, I will get this value. So what is this one? This is nothing but 0.75 milliamps into 4. Okay. So 0.75 is 3 by 4. So that is nothing but 3 volt. Okay. So here it is nothing but I1 plus I3. So I1 plus I3 means where is this is this is 0.25 and this is 1 milliamps. So it is nothing but 1.25 milliamps into 4. So this is nothing but 5. Okay. So 110. 11 means I1 and I2. I1 and I2. That is these two values. These two values. So I need to add these two values. So you will get 1.5. 1.5 milliamps into 4K. Okay. So 1.5 milliamps into 4K is 6 volt. So similarly, for this one, I need to add 1.5 with 1.75 milliamps into 4K. So if I add, I will get this 7 volt. Okay. So the maximum full scale voltage value is full scale voltage value, that is 111 should be 7 volt. Okay. So what is a Vmax value? So Vmax value is nothing but 1000 value. Okay. So if this is 1 volt means this one is 2 volt and this one is 4 volt means 100 must be 100 must be 8 volt. So this I can write it as V full scale voltage plus this LSP value, right? This LSP value. Okay. So VFS I can write it as Vmax minus LSP. Okay. So how to find MSP value? Okay. What is MSP? MSP is nothing but this one, right? So I need to multiply 2 power 2 with this 1 volt, right? So 2 power 2 means 2 power n minus 1. Right, 2 power n minus 1 into LSP. Because here n value is 3, so 2 power n minus 1 is 4. So 4 into the LSP value, you will get MSP value. Okay. So next, suppose if I want to find it is a given question. A system uses 12-bit word to represent the input signal. Okay. If the maximum peak to peak voltage of the output is set to 4 volt. Okay. Find the resolution of the system. And dynamically. See this dynamic range, the formula is 6 dB into number of bits used. So number of bits used is 12 bit. So answer is 72 bit, 72 dB. And resolution formula is maximum voltage, that is 4 volt divided by 2 power n. So here 4 volt divided by 2 power n is 2 power 12, that is nothing but 4 volt into 4 into 10 power 26. If 4 metric. 20104. Okay. So if that is the case, the resolution value is 976 micropool. Okay. So in another way also you can find the dynamic range. The dynamic range is equal to 4 volt divided by this resolution. So 4 volt divided by 976 micro is nothing but 4096. Okay, 4096. So if we take 20 log of 4096, you will get answer as 72T. So we will see about what happens whether we can able to connect the same circuit using non-inverting amplifiers. That is non-inverting terminal. Yes, you can connect the same circuit with the help of non-inverting amplifiers. So next point is you can see the VR voltage that made a variable, right? So if it should be a constant. If it is a variable, then it is called as multiplying DAs. Okay, so it can be, in short, it can be written as MDAC. So the VAC values can be it may be either positive or negative based on the mode which we are connecting. That is either it may be a inverting mode or a non-inverting mode. Okay. So we have to, and it is based on the switches that to be operated. Basically, we can use MOSFET switch. Okay. So accuracy. Okay, accuracy. I mean the stability of an the circuit, that is a DAC. That is based on accuracy of the resistor, right? On their temperature dependence. Okay, because we are using resistance from 2R to 2NR, right? So basically it is very difficult to manufacture such type of resistor, and we can it is very difficult to fabricate the resistor using the monolithic process. Okay, so let us discuss about the disadvantage. So that is what I have already told you. It uses a wide range of resistors, right? So so if it is in terms of megahertz, it should be difficult to process. If, so why we are going for the megahertz means because of the length of the it is based on the length of the binary bits, right? That is n. So if n is increasing means obviously the range of the resistor values also increases. Okay, therefore the fabrication of such resistor is difficult. So next we will discuss about advantage of this DAC. And how to overcome this problem? So since it is not practically possible, we can go for R2 or LED. So the next type of DAC is nothing but R2 or LED. We are using only R and 2R. Okay, if R value is 5K means we will use 5K and 10K value. Okay, we will not require 2 power n R resistors. Okay, so by using that type, we can eliminate this problem, and we can practically we can do it really practical. Okay. So next we will go for the advantage. The advantage is it's very cost wise it is low. Okay, and it's a simple circuit, right? You can see the construction. You can identify it is very easy to fabricate. So I can write the overall voltage value, the output voltage V0 is equal to VR into RF, that is into 1 by 2R B1 plus 1 by 2 power 2 R B2 plus 1 divided by B3 2R plus Bn 2 power n R, right? Tn by 2 power R. So this 2R represent the MSB, most significant bits, and 2 power n represent least significant bit. So this is your output voltage that is being you are getting using this type of DAC, which will convert my current into voltage. Okay, so here the supply voltage need to be constant.